Hey, I must be the only guy who wears a racing shirt and drives his golf cart about 80 miles an hour on the golf course. How about you? Welcome everybody to another edition of the Performance Tour. I'm Scott Moore, your host. You know, on this show, we talk a lot about performance monitoring and observability. But did you know there's more than one kind of observability? We normally refer to monitoring infrastructure and software applications, but there's a newer trend called data observability that you may not have heard of. What is data observability? The simplest definition might be to understand the health and the state of your data across all of your systems. Unlike traditional monitoring, which typically describes a problem, maybe gives you an alert, data observability identifies, troubleshoots, and resolves an issue real time. Sound interesting? Let's go to Atlanta, Georgia, where I interview Ryan Yackel of DataBand AI, an IBM company. Let's discuss, what is this data observability? What does it do? And how can we add AI to make it more powerful? Ryan, thanks for being on the Performance Tour.
What's going on, man?
It's good to see you. So, why don't you introduce yourself and what you're doing these days?
So I'm one of the go-to-market leaders over at IBM Data Fabric, and I specialize in one of our products called IBM Data Band, which is around continuous data observability. So I do a lot of things like talking to people about what we do in the data space. Observability obviously is a big discussion in the software space, and it's become more and more of a discussion in the data space now.
So when you say the word observability, I'm sure the first thing people think about is Datadog, Dynatrace, New Relic, et cetera, and they're thinking, okay, we're monitoring infrastructure. This is not that. So that's why I wanted to have this show to explain what data observability really is.
What data observability is basically a Datadog installed on New Relic, but for data pipelines and data sets. One of the things that you've seen is you've seen a lot of software engineering teams that have grown up in a DevOps culture. They've grown up in we got to deliver and release as fast as we can. We need to use a APM tool or observability tool to monitor things when they get in production, like you just mentioned. A lot of those people are now moving over to become data engineers and platform engineers, and that's all about data. And so just like you need to monitor and observe your infrastructure, your cloud infrastructure, your microservices, things like that on the software side, as a data engineer and a platform engineer, you've got to be able to monitor data pipelines and data sets to make sure there's no things that are, for lack of a better term, looking like they shouldn't, right? You want to make sure that your data pipelines are running perfectly. You want to make sure that there's no anomalous records kind of in there, no null records, things like that that'll eventually screw up the data when it gets to a consumer level.
And this emphasis on data, is that because companies have now finally realized more that data is the gold in the company? It's the gold in the mountain, they say.
Back in when I got started in software, everyone was riding this wave of, everyone's a software company now, right? If you're a banking company, well, no, you're a software company because everything relies on your software. Now everyone's a data and AI company, it seems like today, right? Everyone's coming out with new things. They're building LLM models or using open source LLM models. But the data that these things are consuming, it's only as good as that data. So if you push in bad data or you have data drift that kind of happens, you're going to have a poor experience, both from what your AI product is going to be doing and also the people that are actually using that product in the end state. So everyone, the data is gold, yes, but you got to make sure that it's not copper either. At times, you got to make sure it is gold when you're moving. So,
all right, so you are having to operate just like everybody else as in a DevOps culture these days because everything is continuous, all this continuous delivery of product, whatever it is. But you are facing a little bit of a challenge because you're about 3 or 4 cycles behind where everybody else is at, especially on the traditional observability and other platforms. Can you talk a little bit about that, what that challenge is and the kind of problems you still have to face today?
Yeah, I think so. Our primary people that are in the data observability space are looking for a solution in data observability. They're mainly data engineering teams, data platform teams that have come from I would say a more finely tuned DevOps environment on the software side. They say, hey, you know what, I want to become a data engineer. I move over, I'm doing a lot of things like continuous integration, continuous delivery, and so on. But these teams are extremely underwater, just like the software delivery team. So we always, the software delivery teams are always being put under pressure to release faster without bugs, right? Oh yeah, well, if you want to release as fast as we can, we got to cut down on this and cut down on that. But we got to release as fast as we can because we want that, our business wants us to release faster. The same thing is going on with the data engineering team. They're consuming 80 to 90% of all data in their organization. And at times they can get sloppy in how they're actually delivering their data because they don't have time. They don't have enough time in the day to actually get the data, clean the data, move the data to where it gets actually consumed. And so I would say that the challenges in the DevOps culture on the software side are also some of the challenges on the data ops culture, the DevOps, data ops culture on the data engineering side is that they're constantly being forced to consume complex data, high volumes of data at rapid speed. And if they don't have something that catches these things before it's too late, we all know a bug caught in production is way more expensive than a bug caught when you're actually getting ready to release it, right? Or even in a staging area.
So Ryan, tell me a bit about how your product uses AI to make it better or as a force multiplier.
I'm a part of the IBM Data Fabric solution set within IBM. So there's a lot of different products that IBM offers when it comes to fully building up your own LLM models or governing those LLM models or designing products with AI. And then there's like the producer side of that, which is around Data Fabric. So that's more, first I talked about more of like a Watson X kind of solution. Data Fabric is all the things that you need to do to produce it to where it gets into a steady state to actually consume it. And then part of that Data Fabric is Data Observability. And so what our solution does, there's like two areas where we help out in that. One is our own AI ML capabilities, which is what we're doing is we're looking at a lot of the historical records on your data pipelines and data sets, and we're automatically telling you when they look anomalous and when there could be a deviation in the expected behavior that you have, so you're not having to go in and manually figure that out. So that's one thing that we do when it comes to anomaly detection. That really pairs over into a lot of our customers are using data observability to make sure that then that data, if you catch that bad, you can fix it in lieu of if you don't fix it in time, because all that data is being pushed to like an LLM model, for example. So we have customers that are using a full stack of pushing, using IBM Data Fabric pipelines all the way to being consumed by Watson X and building AI products off of that. We also have solutions where, or customer use cases where they've got things like Apache Airflow that's using orchestration. So they're taking data, orchestrating it, transforming it, and pushing it to their own LLM models, or using something like SageMaker within AWS. All those pipelines and data sets, all those feed those predictive models. If you don't catch those issues before they get into a consumption layer, you're going to have problems like garbage in, garbage out.
Let's talk about that for a second, because you mentioned LLMs. Right, so everybody now wants to build their own generative AI solution.
Yep.
If you get bad data in those systems, they consume so much data. But then if they get bad data, you pretty much poison the whole system. It's not reliable. Can you talk about the ramifications of that and how you can maybe prevent that problem?
Since a lot of the AI components are being driven off of these models, if, let's say, there are decisions or business decisions being made based off of that, you open yourself up to a lot of liability issues. And so one of the things, I think in this space, we've talked so much about what generative AI can do and AI-powered products can do, but what we haven't really addressed is the governance around those LLM models. Right. And so you can look for things like biases within these LLM models. If you don't catch those, that's a problem. How much data they're actually consuming as well. You had mentioned that. Just like a data warehouse in the cloud, you store a bunch of data in there and it's rarely consumed. Around 80% of data, I think, within warehouses now, like they're just not consumed, right? Same thing could happen with an LLM model. You're pushing all this data in, you don't know if it's good or bad, and now your costs keep going up and up and up and up. It's like the surprise hyperscaler bill that you get, and you're like, oh gosh, I forgot to turn that thing off. Right. Downstream effects are opening up to liability, potentially of using the products in an incorrect way or consuming data in a way that's not protected in a way that it should be. Obviously the poor user experience we had talked about in doing that, but then outside of that is the cost angle. So all those things kind of play into the things you need to be thinking about when you're actually deploying these LLM models to be used in AI products.
So Ryan, when I think about performance engineering as it may apply to this, I think of it's not just about making something faster, making these pipelines faster, because speed for the sake of speed is not necessarily a great thing. It needs to be controlled. I'm thinking about efficiency. So wringing out everything that I can out of the infrastructure that's being used and just making sure that you're getting the most bang for the buck. So how can we apply performance engineering to data observability, making it fast but efficient and making it better? How is performance engineering a part of data observability?
I like to say that there's like three things that observability is trying to help the data engineering do. One is detect things earlier. The second one is improving your mean time to resolution. So instead of just saying, hey, something went wrong, it's, hey, something went wrong, here's the downstream impacts of it, here's the root cause analysis, here's how to go fix it, right? You've got to be able to do that. The third thing around is like, if you have these things in place, you're able to then guarantee and meet your data SLAs. You're able to meet those types of things. And so I would say those are like the core tenets of what observability is doing from a performance and efficiency side. Outside of that, there's a lot of other use cases for observability. So one of the things that we can do is look at the number of records that are coming in, and if the records being written or read are slowing down or speeding up, that tells us there's a resource issue, whether we have too many or too little resources being allocated to a pipeline or an orchestration tool that we may have, right? So that allows us to go, oh, there's an issue with us being able to perform at the most optimal level, both in cost and also with speed, right? So we can go and address that. Lots of other observability use cases out there are around things like, are we optimizing our cloud spend? Are we optimizing the tables that are within a Snowflake instance, for example? More of like a FinOps kind of angle to it. So that's another area where I think data observability will help with at least the data space and making sure you are performing the best you can within the cost that you have as well. And not, like we said earlier in a previous video, not just running up your cloud spend just because, or you're not consuming records you may not need to consume.
Right. So you said one of the challenges that you face in data observability is that you're just a little bit behind because now there's this emphasis on it, but now you're seeing some of the same things that you saw in software engineering maybe a couple of years ago. So how do you catch up, and where do you think data observability goes in the next 12 to 36 months?
Yeah, so I mentioned to you, I was reading a paper the other day, and I said things, if you took the phrases data quality, data reliability, data downtime, data issues, and you just replace that with software, right? Software quality, software reliability, software downtime. Very similar stories are going on in the software space and the data space. So I think that the way observability is going, there's really, like, I would say, probably three areas that we're monitoring, at least within IBM. One is the modern data stack and the amount of complex tools and resources you're using within a modern data stack that need to then have an observability layer over that. So as you add on, like, let's say a Python pipeline, or you say, I want to use Azure Data Factory for my pipeline orchestration tool versus Airflow, or I want to use Spark or Databricks or something, whatever it is, all these different tools that are out there. So one is getting a full landscape around the tools that are out there under this observability angle. Very similar to that, software DevOps explosion of tools. The same thing is going on and with data. I would say the second one comes to around actually monitoring the traditional data quality rules you may have in an organization today and pairing that with a governance angle with data observability. So when we talk about data governance, it's usually looked at through an angle of completeness, freshness around the data. Maybe it's a traditional data quality tool that's more of like a catalog solution. We're seeing a lot of people recognize observability as another layer of data governance. So that has a lot of implications for a CDO or somebody who's head of data at a company, because they hear governance and they go, oh yeah, we need to make sure that we're doing right with the data we have, and observability could be an angle to that. And then the last angle, I think, is just like the real-time processing of data that's heating up more and more and more. And so We see a lot of companies still doing ETL type batch or reverse ETL. They're doing a lot of, I would say, non-streaming of their data. And as more companies come out with like adopting solutions, open source solutions like Apache Kafka, Confluent is a hosted solution that's like that. There's a lot of companies that are starting to ditch the ETL process to move data and go straight to streaming. And as we know, as like you get faster and faster and faster, you're gonna have to layer in an observability angle, not just in your ETL process, but also your streaming process. So that's why I would say three things we're looking out for: the proliferation of the modern data stack and how tools are being used there. The last one I talked about, which was the ETL streaming, and then also looking at, hey, how can data observability be another pillar to data governance? I think you'll see a lot of those things happen in the next 3 to 6 months.
Thank you so much for being on the show.
Man. Thank you. Using data observability tools is essential if you want to get ahead of bad data issues in production, which strikes at the heart of performance and reliability. Using AI alongside these tools can give you faster results and pinpoint accuracy that humans might not be able to match. It should be part of your entire data lifecycle if you want to protect all of that gold, that data in your business, and keep it from becoming a liability. Has your company already implemented a plan for data observability? Maybe you've already been through this. I'd love to hear your feedback and experience. You can leave a comment in this video or contact me through the website where you can watch all the previous episodes of our show. Thanks again for watching. I'm Scott Moore, and I'll see you on the road